Carlo David,
Santos.
and we are the Team Explorer.
We will make a series circuit. First, we must know what are the materials we will use.
First,
Battery,
battery,
LED lights,
wires,
illustration board.
scissor, and what we have here is a tester.
So, first we must draw outline.
Then,
We are done. So, we will assembly the circuit. Ayun. But before that, we will check how bright the LED lights. Oh,
wait lang.
see? And now let's find out how bright the LED bulb after you put at the series circuit.
So here is the positive, and we will connect it to the negative of the other LED light. And then this is the positive, and
Ito na negative. So,
the positive and the negative. What do you call that? Sige na. Baliktad.
change position.
Okay. Zoom.
The cleaner than the first one we made.
It looks like Christmas lights.
That's
Twinkle,
all.
twinkle.
Tara.
Game. One, two, three, go.
This is how to solve a series circuit.
Ano? Oo.
You see that we have a 3.7 volts battery and two LED which have 23 times 10 raised to 3 ohms resistance each. When we place all of them as a circuit, we can solve for the value of the voltage, capacitance, and the power supply of each resistor or LED. In series, we have the total voltage by the summation of all the voltages in the circuit. The total current of the whole circuit is just equal to the current of each resistor. The resistance and the power of each resistor is the summation of the resistances or powers.
To find the resistances of each resistors, first we are going to find the equivalent resistance. To get the equivalent resistance, we are going to redraw our circuit. We have our formula. Req is equals to R1 plus R2. R12, or equivalent resistance, is equals to 23 times 10 raised to 3 ohms and 23 times 10 raised to 3 ohms. The sum of the two, the equivalent resistance, is 46 times 10 raised to 3 ohms. To get the current of the whole circuit, we are going to use the formula V is equals to IR. Equate it, we will have I is equals to V over R. Our I is equals to 3.7 volts all over 46 times 10 raised to 3 ohms. We will get an answer of 8.04 times 10 raised to 5 ampere. We have our required. First, the V1 and the V2. Second is the P1 and the P2. We will get the V1 by our formula V equals IR. V1 is equals to I multiplied by R1. V is equals to 8.04 times 10 raised to negative 5 ampere multiplied by 23 times 10 raised to 3 ohm. We will get an answer of 1.85 volts. 1.85 volt is equals to our V1, which is equals to our V2 because they have equal resistance. We will get our P1 and P2 by our formula P is equals to VI. P1 is equals to V1 multiplied by current. P1 is equals to 1.85 volt multiplied by 8.04 times 10 raised to negative 5 ampere. We will get an answer of 1.4874 times 10 raised to negative 4, which is equals to our P1 and our P2.
And now we're gonna make a parallel circuit using the same LED lights and the same battery. And now Eller draw a parallel circuit. And now we have a drawing of a parallel circuit. And Eller gonna put holes at the resistors and at the batteries. And then, same LED lights and same batteries as we use at the series circuit, gonna put them in the drawing, like that. As you can see, the light of parallel circuit is more brighter than the series.
In our parallel circuit, we also have our 3.7 volts battery and two 23 times 10 raised to 3 ohms resistors or LED lights. In parallel, our total voltage is equal to the first voltage or the second one. The current is the summation of all currents in the circuit. The resistance is 1 all over 1 over R1 plus 1 over R2 plus 1 over Rn. The total power is equal to the summation of all power in the circuit.
These are the ones we are going to solve. The total volt, the V1 and the V2. The total current, the I1 and the I2. The total resistance or the equivalent resistance. The total power, the P1 and the P2. First, we are going to get the total volts. The total volts, we can get 3.7 volt, which is equal to V1 and V2. To get our equivalent resistance or the total resistance, we're going to use the formula 1 over R1 plus 1 over R2, which is equals to 11.5 times 10 raised to 3 ohm. To get the total current, we have V over R from the formula V equals IR, which is equals to 3.7 volt all over 11.5 times 10 raised to 3 ohm. Our total current then is 3.22 times 10 raised to negative 4 ampere. To get the I1, we have V all over R1, which is equals to 3.7 volts all over 23 times 10 raised to 3 ohm. Then we can have the answer 1.61 times 10 raised to negative 4 ampere, which is our I1, and is equals to I2. To get the power, or the total power, we're going to use the formula P equals to VI. The total power is equals to total volts multiplied by total current. The total volt is 3.7 volts, and the total current is 3.22 times 10 raised to negative 4 ampere. We can get the answer for the total power, which is 1.1914 times 10 raised to negative 3 watts. To get the first power and the second power, we're going to multiply the total volts multiply by the first resistor, multiply by the first current or the second current, which is equals to 3.7 volt multiplied by 1.61 times 10 raised to negative 4 ampere. Then we can have the answer 5.957 times 10 raised to negative 4 watts, which is our P1 and is equals to P2.